I'm going to go through these two questions that you were unsure about, question 10 and then 11 from section 3.1. So question number 10, examine the parabola shown to the left. So they're talking about this one right here. Copy and complete this table. And then there's some other parts. So let's do the copy and complete the table part first. So I'm going to flip over here and I'm going to just write out a rough version of that table. 10a, this is section 3.1. So I've got my x values, I've got my f at x values, -2, -1, 0, 1, 2. And then I have to read the f at x values off of the graph. They are the y coordinates. So for example, when x is -2, which is right here, y is +3. So if I go over here, I've got +3. Okay? And then if I have x at -1, that's right here, and the y coordinate is 4. Okay? So you might want to pause the video and write down, make your own version of the table. I'm just going to fill it in because I have done this a bunch of times now because I keep messing up, skipping between screens. Okay, so I know that this is 4, 3, and then 0, and then -5. Okay, and if we look back here, so 4, and then when I go to 0 for x, the y coordinate is 3, and then when I go to 1 for x, the y coordinate is 0, and then all the way down to -5 when x is 2. Okay, so that's the first part done. Copy and complete the table. Second part, calculate the second differences. Now, to calculate second differences, I first need to calculate first differences. Okay, and this is just the differences between y coordinates. Okay, so I've got those listed in my table, and I'm always going to do number on the right minus number on the left. Okay, so here to get the first difference, it's 4 minus 3, so that's going to be obviously 1. Okay, and then here I've got 3 minus 4, which is, in this case, -1. And then here I have 0 minus 3, that is -3. And for my the last of my first differences, I have -5 minus 0, which is -5. Okay? That's first differences, so just difference between the y values. The second difference is, I'm just going to take the difference between those ones that I just calculated. Okay, so in this case, I've got -1 minus 1. -1 minus 1 is -2. Okay, and for the next one, I've got -3 minus -1. Okay, so it's a difference, so I'm always subtracting, but when I subtract a negative, it's the same as adding, so I end up with -3 plus 1, -2. And then my last pair of numbers, I've got -5 minus -3, so that same idea of working with integers, -5 plus 3 is once again -2. Okay, so you'll see that your second differences are all the same, and they are all negative. Okay, now the connection between the sign on the second difference and the parabola that we see here, so you'll see here, how could you have predicted their signs? Because the parabola is opening down, I could have guessed in advance that my second differences would all be negative. Okay, so parabola opens down, and then I'm going to use this symbol for therefore because I'm lazy. Opens down, therefore second diffs are negative. Okay, number 10, that's what they were talking about. Okay, so that idea of second differences, we have to calculate the first differences first, and then there's a connection between the sign on the second differences and the direction of opening of the parabola. So if this parabola opened in the up direction instead, okay, then you can imagine the second differences would have been positive. Okay, the last part of number 10 is to determine the equation of the function. So to do that, I need to pick out a key point. And there's a couple key points, and I have two options. You've seen vertex form, which uses the coordinates of the vertex. You've also seen the factored or zeros form, which uses the zeros. I'm going to pick vertex form. I find it a little bit easier, but you could do, if you wanted to redo this question on your own, you might want to try doing it in the factored form that uses the zeros. Okay, but I can see right here the coordinates of my vertex are -1 for the x and +4 for the y. So I'm going to go over here to do part C. Vertex is at -1 for the x and +4 for the y. Okay, and then the vertex form of a parabola in general looks like this, where h comes from the x coordinate of the vertex and k comes from the y coordinate. Okay, now the last thing is this a value, which can be a little bit tricky to figure out, but we've actually kind of already done the work we need to do to figure out the a value. It comes from the second differences. Okay, the -2 that I calculated here, that would be my a value if I found it some other way. So my actual equation here is going to be x minus -1, so x plus 1, plus 4 on the end. And then for a, I'm going to put in -2. I calculated that in the second differences. Okay, you could have also found this -2 using some algebra by subbing in numbers for x and y and then calculating a, but because we already did the work up here, may as well use that instead. Okay, that is number 10, all done. Number 11, I actually think it maybe makes sense. I linked you to Desmos, which is a graphing calculator. And I actually think this is a good opportunity to use that. So the number 11 says the height of a rocket above the ground is modeled by this quadratic function where h at t, so this piece right here, is the height of the rocket in meters, and t is the time after the rocket was launched. And it asks you to graph the function first, and obviously you can make a table of values on with a pen and paper and do that, but I mean, since we're using computers to do so much of this stuff anyways, we may as well just graph it, okay? So if you click on the link that I provided for the graphing calculator, this is what will come up. So, wrong window, nope, not that either. This one here. Okay, so -4, and then the only thing about the graphing calculator is it uses x and y, but obviously we're using different variables on the page here. I can just switch out this is y, and then t is x. So -4x squared plus 32x. Okay, so y equals -4x. And then I think if you click that right there, it'll bring up some options, plus 32x. Okay, and let me just double check that I got that right, plus 32x. Okay. And then we can just zoom out until we can see the parabola. And we can even set our axes so we can see like my x-axis. I only really need to go from like -2 to maybe 10. And then my y-axis, my vertex, oh, that looks pretty good. Okay, so you can click on this and then you can adjust what it's showing just so you get a better picture of the graph. Okay, so I've graphed my function. So that is part A done. Okay. How long will the rocket be in the air? How do you know? So going back to my graph here, I should be able to use the graph to answer that question. So how long will the rocket be in the air? So it was launched at 0 seconds. The vertical axis represents the height. Okay, so it looks to me like it went up, 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 up. It reached its maximum height at 4 seconds, and then it came down, 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 and it landed back on the ground. That's height 0 at 8 seconds. Okay, so if I go here, number 11A on Desmos, and then B, it was in the air for 8 seconds. Okay. Question C. How high will the rocket be after 3 seconds? So here, I'm going to look at my picture. So 3 seconds is right here. I follow my graph along, and you can even click and hold to see the coordinates. Okay, so at 3 seconds, the height is 60 meters. Okay, that's the point that it's showing me right now. So I'm going to go back over here, and I'm going to say C, 60 meters. Okay, and then what is the maximum height that the rocket will reach? So I look back at my graph one more time. And so the maximum is right here. It actually, Desmos has kind of already noticed it for me. So after 4 seconds, I reach a maximum height of 64 meters. So I'm going to go here, D, 64 meters. Okay, and then let me just go back and read. Oh, and that's it. Okay, so pretty easy. I can just graph the function using Desmos. Hopefully, if a question like that comes up again, you'll take advantage of that tool, because I know that graphing by hand can be a little bit frustrating. And if you do make a graph on Desmos, if you could just take a screen cap, or if you can even export the graph like this. Okay, so export image, and then you can attach that when you upload pictures of your work for me. Okay, and that way you don't have to worry about graphing by hand so much. One of the advantages of remote learning. Okay, hopefully this was helpful, and have a nice day.